Hey everyone. So this is going to be the third video in my Rat Run series, or rather my series going through Marty Sears's Rat Run puzzles. This is the third puzzle, and it's the first full 9x9 puzzle, so the aim is to put the numbers 1 through 9 in the puzzle so that every row, every column and every 3x3 box includes every number exactly once, subject to a few additional constraints. For this puzzle, so normal Sudoku rules apply, which I just mentioned, and then we have to help the rat get to the cupcake. We can move up, down, left, right, as well as diagonally if there's a 2x2 space in which to do so. And then the additional constraint, so first, black currents. Cells connected by a black current have a 1-to-2 ratio. One is double the other. Not all possible black currents have been given. So I'll explain what that means. It's these black dots here. So what that means is I could do something like I could put a 1 here and a 2 here, right? This is allowed because one number is double the other, right? I could go 2 and 1 the other way, like this. I could go 2 and 4, 3 and 6. I could even go 4 and 8, like that. But I can't do something like 4 and 7. This is not allowed. So, in any situation, or I could go like over here, same thing, or 8 and 4 this way. One number has to be double the other on either side of this black dot. When it says not all possible black currents have been given, what that means is it's totally fine if we want to go somewhere else and do something like this, for example, right? It's not saying that there's one number is double the other if and only if there's a black dot separating them. It's just a one-way implication. Black dot means there has to be one number double the other, but you could also have one number next to the other number being... You could have this situation somewhere else without a black dot, right? Okay, that's what those black dots are. And then the test constraint for this puzzle: in this experiment, the correct path will be a valid Dutch whisper line. Adjacent digits along the path must have a difference of at least 4. So that's a standard constraint in a lot of Sudoku puzzles that you might see. What it means is, I'm just going to pull out the pen tool here. Let's say that the rat goes, let's just make a simple path like this. This is probably not the real path. But what this means is, anywhere along the line, if I put, let's say, a 2 here, then this number, which is next to it, has to be at least 4 away from 2. So it could be 6, because that's exactly 4 away from 2, or it could be even further. It could be 7 or 8 or 9, but it could not be 5, right? That's only 3 away. That's not far enough apart. It's kind of similar to the last puzzle, where any 2 adjacent digits, so here, 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 anywhere along the line, right? 2 numbers that are next to each other have to add to at least 10. That was the last puzzle that I did. This one is different. They have to subtract to at least 4, right? So that is the puzzle. If you want to play, the link will be in the pinned comment along with all of the settings that you need. And now is your last chance to start before I get started, which I will in 3, 2, 1. We're starting the timer. Alright, so as usual, the first thing I'm going to do is I'm going to connect all possible paths in gray, and then, and then just delete them as I find that they are no longer possible. That's something that I've been doing in all of the puzzles so far. As you can see, I think it really helps, even though it might be a little bit overkill. It does waste some time at the beginning, but I feel like it does help me to reach some conclusions that might otherwise have taken slightly longer. And let me just make sure I've gotten all the 2x2 spaces. Yes, I have. Okay. So we actually know very little about the path of Thinks the Rat here. I don't even know where it starts to move. Okay, well, one thing we can say is if you look at all of these, so there's a couple things we can say. First of all, I'll talk about the black dots. So what are all of the different ways of having one number be double the other in terms of like valid Sudoku digits? It could be a 1 and a 2, or it could be a 2 and a 4, or it could be a 3 and a 6, or it could be a 4 and an 8, right? But a black dot can never have a 5, a 7, or a 9 on it, right? Because then what would the other number be? Those are all odd numbers, so I can't cut them in half to get the other number. But I also can't double them because that's going to be too big, right? If you double 5, you get 10. If you double the others, you get an even bigger number, right? 3 is fine because that's small enough to where I can double it to get 6, right? But those are the only valid numbers to put on a black dot. Okay, and then let's talk about this gray line here. So let's think about how these numbers might be distributed among the line. So, actually, I've noticed something else. Oh, no, I can't use that yet, but I will when I get to it. So anyway, sorry, I get distracted easily. So the black line, or the gray line, or whatever the actual path that Finks takes, let's say it goes over here. Now, what that means is, let's say I've got a 3 here. Yeah, okay. I'm going to, you know what? I think something that's going to help a lot for this puzzle is high-low coloring. So, what I'm going to do is, I am going to color all of the numbers 1, 2, 3, and 4 in orange, and I'm going to color all of the numbers 6, 7, 8, 9 in green, and I'm going to color the number 5 in black. Or is black going to work? Is that's not too dark? Okay, good. Because, well, I'm going to say something and then I'm going to qualify it a little bit. So, this black line that Finks is actually taking here is going to have to, for the most part, alternate between high and low numbers. By which I mean, you have, if I have a low number like 1, 2, 3, or 4, I'm probably going to have a 6, 7, 8, or 9 next to it, right? The only number far enough away, if I've got a 4 here, the only number far enough away from 4 is 8 or 9, right? If I have a 3, then this has to be a 7, 8, or 9 in order to be far enough apart. If this is a 2, then this can be, well, it can be a 6, 7, 8, or 9, right? But I guess the only exception is if this is a 1. This doesn't have to be a 6, 7, 8, or 9. It doesn't have to be a high number. It could also be a 5, right? So 5 can go next to 1 or 9, right? And then vice versa. You can see that it's going to work in the other way. If I've got a 6 here, this has to be a 1 or a 2. If that's a 7, this has to be a 1, 2, or 3. If this is an 8, this must be a 1, 2, 3, or 4. And if this is a 9, well, this probably is going to be a 1, 2, 3, or 4, but I suppose it could also be a 5, right? So this line is going to alternate between high and low numbers, except where you go from a 1 to a 5 to a 9. So if this is low, for example, if this is low, this is high, 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 and so on, unless, let's suppose that, ignore this black dot for a second. No, let's just do this. Suppose that this is a 1, right? This could then be a 5, and then I go to a high, which is 9 specifically. Now, a 9 can't go in a black dot, but suppose it could. Then I would do this, and then the alternation would continue. I could maybe, flip somewhere else, like this. So we go orange, green, orange, black, green, orange, green, right? So you can reverse it. But the only way of reversing it is a 1 to 5 to 9, right? I suppose you could also go like 1 to 5 and then back to 1. Hopefully that made sense. Sorry. Okay, so that's the list of allowed partners. Now I'm going to look at this. Yes. Okay, so something I've noticed here. Suppose that the rat does travel along this path here, and it goes through this black dot. Well, what pair of numbers is on this black dot? It can't be 1 or 2, because they're not far enough apart. It can't be 2 or 4. It can't be 3 or 6. It could be 4 and 8, because those are exactly 4 apart, so those are just far enough apart. But either the rat goes this way and runs into a 4-8, or it goes this way and runs into a 4-8. So either way, this is a 4-8 or this is a 4-8. Whichever one is on the path is the 4-8. And that's the case for any black dot that's on the path. I just noticed this situation specifically because we are forced to take one of those two paths, as well as one of these 3, I've noticed. But that doesn't really get us anywhere. I have no idea where to look. Maybe look down where the cupcake is. That seems even more wide open. Maybe there's some other reason why I can't go around this way. See, that's what we have usually done, is try to disprove, being able to take up an entire row, column, or box because of some mathematical restriction. I'm going to mark this path because I believe it is probably wrong, and I'm going to see if I can figure out how. So this would have to be a 4 and an 8. I don't actually think it matters in terms of like row logic where the 4 and 8 are, but just for the sake of completeness, I'll test both. Suppose it's this way. Then what is on the other side of this 4? Remember, a 4, I have to have something far enough apart from the 4, which has to be an 8 or a 9, but the 8 has been used, so it must be 9. Then what? I mean, this can be basically any low number, right? Gosh, I don't know. It could be, yeah, 1, 2, or 3, but that doesn't narrow it down at all. I mean, this would be like 5, 6, or 7, I guess. Yeah, then it just gets completely out of control. This has to be a 1, 2, or 3. Actually, this could be a 5 as well. That's a 1, 2, or 3. Yeah, that doesn't quite do what I thought it would. I am going to be honest, I don't know where to begin with this. I didn't miss any rules, did I? No. Okay. I hate just having, like, just dead air, just silence, where I'm not talking about anything. Oops. There's another puzzle variant called German Whispers, where the numbers have to be 5 apart. And you can start high-low coloring the line. But I can't do that yet, because it could have like a 1-5-9 situation, right? I do know that if this path were used, one of these would be high and the other would be low. Gosh, there's got to be something super obvious that I'm just not picking up on here. This is going to be awkward. Maybe is there some reason I can't go this way? That feels easier. No. Like, is there some reason why I can't take up every single... Oh, well, you know what I do have to do. Yeah, suppose the rat does move this way. Now, where does the 5... Maybe the 5 is the thing to look at. Where does the 5 go in this row? It can't go here, so it must be here. It must be on the path. I see no issue with that. Well, if the 5... No. I'm just looking at something completely wrong. I solved this in like a half hour the first time. I don't even know where to look. is there some reason why I can't... I mean, this would be a 4 and an 8. Maybe I can look at where the 5 is. If this is a 4, 8, in some order. I mean, this then can't be a 4 and an 8, but that doesn't really narrow it down at all, because the rat doesn't have to travel there. So I'm just going to say that one of these is high and the other is low. I'm not saying right now that orange is high and green is low or the other way around, but orange is one parity and green is the other. This would then have to be orange, or sorry, that has to be green. This has to be orange, right? Because I can't change parity. I can't do the 1, 5, 9 trick here because this is neither 1, 5, or 9. If this is a 4, this has to be a 9. And if this is an 8, this has to be a 1, 2, or 3, so no 5s allowed. But then I could change parity somewhere else. Again, I just don't see... I'm not gonna... I hate doing this. I'm not gonna restart the recording, you know, after I find, like, the first break-in, but... Oh, well, I guess, you know what? Oh, no, I see. This is very clever. So... No... I was going to say something that I thought was smart, but actually is not. Okay. Well, I can say this. Here's something I can do. Yes, okay. So this is not a statement about where the rat immediately travels. Let me actually go ahead and put these center marks back in. But here's something that is a little bit interesting to me. The only time the rat can go through a black dot is if it's a 4, 8. Now, I want you to have a look at this hypothetical path here. So it goes through here, and then does something else. I don't really know what. Is this possible? I claim that it's not, because this has to be a 4 and an 8, and this has to be a 4 and an 8. But that's not possible, because then I have 3 squares in the same column that are all 4s and 8s. But that's not possible, because it's just 2 numbers going into 3 squares. And I can't have a repeated number in a column. So that does not work. And in fact, we can generalize this. We can say that if the rat, we could say that about this column as well. If the rat uses this black dot, it can't also use this black dot because they would both be 4 and 8. That's somewhat interesting. I wonder, this black dot seems very hard to use. Actually, okay, this one definitely can't be used. Because look, if I were to use this black dot here, this has to be 4 or 8, right? But where does this end of the path lead? It must lead up this way through this black dot, not that I care about that, but then it must also go through this square. And then I've got this square, and this square, which are all 4s and 8s. But that's not possible, because I would have a repeated number in the column. And this probably would... Well, I guess it could also go this way, but that doesn't matter, right? The point is, this black dot cannot be used. I can't travel across it. And now I can just get rid of these dead ends. Okay, that's sort of interesting, actually. Is there anything else I can say? Now, they still do have to be 1s, 2s, 3s, 4s, 6s, and 8s, but they don't have to be specifically a 4 and an 8. That is actually rather interesting, because now I must use this path. Do you see? There's no other way. I've sort of divided the board into 2 regions. There's this upper region that I'll mark in pink. And then there's this lower region that I'll mark in red. there's no way for me to get from the pink area to the red area without using this as sort of a bridge, right? So this black dot must be used, and therefore must be a 4 or an 8. Okay, this is how we're going to break into the puzzle. Alright, now I've seen something else very interesting. These are 4 and 8. So this can't also be a 4 and an 8 because they're in the same 3x3 box. So we can take a 4 and an 8 out of here, and as a result, we cannot travel across this black dot. Is that right? Well, no. Okay. It is true that we cannot travel across this black dot, but it does not mean that we cannot visit those squares. We certainly can't visit this square because it's a dead end, but we could do something like this, right? We could go like 4, 8, 3, and then continue, right? I just can't travel across the black dot, but I can still use a square that is on one side of a black dot. So I must be very careful that I don't accidentally delete a path that actually is possible. By the same logic, this row already contains a 4 and an 8, so this cannot be a 4 and an 8. And therefore, I may not use this black dot. Actually, if this is not a 4, then this cannot be an 8. But, so I cannot use this path here, so I must take this off and this off so I don't run into a dead end. Actually, I now have to do this. Oh, this is interesting. I can't travel across this black dot, can I? Because that would be a 4 and an 8. And then I would have 3 4s and 8s in the same column. Right? If this was a 4 and this was an 8, then what the heck would this be? So I can't actually use this path. And now I must go this way around. It could still be a 4 and an 8. One of them, I could have like a 4 and then a 2. And then this is an 8. That's totally fine. I suppose this couldn't be an 8. But yeah, if this was an 8, then that's a 4 and that's also a 4. So we can take an 8 out of there. Not that that does a whole lot for me now. Actually, same thing here. That can't be an 8. Because then that's a 4. And that's, I guess, that can't be anything. So you can take 8s out of there. That's something, I guess. Okay. But like this could be a 4 and that be a 2. Right, that's totally fine. Or you could have a 4 and a 2 here. Okay, anyway, we travel this way. Oh, okay, so now this has to be a 4 and an 8 as well. And now I definitely cannot use this black dot because this would be a 4 and an 8. And now I have 3 4s and 8s in the same column. Okay, now we're getting somewhere. So we can't go this way around. And, well, okay, this can't be a 4 or an 8. This can't be an 8 because then this is a 4, which breaks this black dot. But this could still be a 4 because that would be a 2, and that's totally fine. But as I suspected, we are going to have to go this way around. Now, this has to be a 4 and an 8. So I'm going to take all the other candidates out of here. This cannot now be a 4 or an 8, and I may not use this black dot. Okay. Now, this is rather interesting. Again, I have this situation where I have sort of this, this end of the path here, which I'll mark in pink. And then I have this sort of region of the grid down here, which I'll mark in red. And I ask you, how can I go from the pink area to the red area, which I must? I have to use this path here. I don't have to use this path. I could go the other way around, but for sure I have to go here. That's the only way of connecting this area to this area. So let me get rid of this coloring. So this must be used, for sure. And I can either go straight there or I can go this way. Alright. Interesting. Oh, you know what? I can actually just take a 4 out of here because it's in the same box as this 4-8 pair. You guys probably noticed that a while ago, so. Yeah, sometimes I just like forget like the normal Sudoku rules about rows, columns, and boxes. I don't know why. Alright. Well, this row now has a 4 and an 8 in it, so this cannot be a 4, because it would turn both of those into 8s, and then the 8s would see each other. So that's not a 4. This could still be a 2, though, connected to a 1. And this could still be a 4, I believe, couldn't it? Yeah, it barely could. This would be a 4, 8, 4, 8, 4, and this is an 8, and that's a 4, but that's fine. Okay. Huh. Alright, well, we're getting somewhere at least. I feel like this area of the grid, there's got to be some reason, like, they wouldn't have, the puzzle creator, Marty Sears, would not have even put this in the puzzle if it wasn't used, I feel like. It leads me to believe that I need to try to disprove the usage of this connector here, but I can't quite see how, at least not immediately. Well, let me have a look at this. Yeah, take a look at this square. Could this be a 6? It couldn't, could it? Because this is either a 4, which is too close to a 6, or it's an 8, which is also too close to a 6. It has to be 4 away. So that's definitely not a 6, which means this can't be a 3, because a 3 can only connect to a 6. So I can take a 3 out of there. It could be still 3, 6 this way. Or could it? Maybe at some point it's worth coloring this path. Well, I can't quite color it, because I can still have like a 159 transition at some point. So coloring it doesn't... Oh, well now, this has to be low. Yeah, there's no way for this to be a 4. This was actually even easier than I realized. If this is a 4, this has to be an 8 or a 9. But we've already eliminated 8 and 9 from this square. Those are the only things that are far enough away from 4. If this is a 4, what is this? It'd have to be 1, 2, or 3, but those are all too close. This must be an 8, and we finally got a number in the grid. So that's an 8, that's a 4. And I actually will go along with the high-low coloring here. So this must now be low. It doesn't mean that this is high, because it could be like 1... Oh, no, it can't be 159, can it? Yeah, because this would be a 9. Yeah, so this has to be low, high, low... Or, sorry, high, low, high, low. That's not a 1, 5, or a 9. Well, it's definitely not a 5. Yeah. That's high. So, in fact, it must be 6. That's low, but it could be a 1, which lets this be 5, so I can't mark that in black just yet. So let's go ahead and finish this up. So that's low, so it's a 4. That's high, so it's an 8. That's high, so it can't be a 1 or a 2, so that's a 6. And a 6 is only connected to a 3. Okay. So this, in fact, cannot be a 3 or a 6. And so that's a 1 or a 2, and it would connect to a 1 or a 2 here, because we've already taken a 4 out. We can probably make a few other eliminations, like that's not 3, therefore that's not 6. This, oh, you know what? This 8 sees this 8. So if this was an 8, they'd see each other, so that's got to be a 4, that's an 8. So we can color them like so. And now this is interesting, because how do I color these squares? If I try to continue this alternation, high, low, high, low, high, low, now I have 2 lows next to each other, right? So I have to go, because these are an odd number apart, right? So I have to have a black in here somewhere. So there must be a 5. It's got to be a 159 transition. Actually, the 5 can't be here, because the 5 and the 4 are way too close. So the 5 must be here. We'll color it black. So that's green. And in fact, it must be a 159 transition like this. For that matter, this is going to be low. Maybe we can start to, like, oh, here we go. This, well, in order to be far enough apart from 8, I can't go up 4, because that takes me to 12. I could go down 4 to be a 4, but a 4 is already used, so it's got to be a 3 or a 2 or a 1. This, oh, this has to be far enough away from 6. I can't go up to 10, so I must go down to either 1 or 2, but 1 is already used in the row, so that must be 2. Here, same thing. It has to be far enough away from 4. Oh, you know what? This could be an 8 or a 9. It doesn't actually see either of these 8s, so that's still okay. It's for sure an 8 or a 9, though. That much I can tell you. This is definitely not a 2 or a 1 because it's in the same box here. Alright, so what is this? It can't be a 1 because it would connect to a 2. That's the only elimination we can make there. Okay. Now what? Oh, well, you know what? We can't use this path. Because whatever this is, whether it's a 1 or a 2, it would be too close to this 4. Right? So we can take this off, and now we must go this way around. And through here. We just don't know whether we go the top or bottom this way. And we definitely don't know what happens down there. We can now color this low. Actually, we can color this low and this, because they're 1s, 2s, or 3s. I know I'm coloring them even though they're not on the path, but I can still use that trick of, you know, every row, column, and box has to have 4 lows, 4 highs, and then the black, which is the 5. Okay, what is this? That's an 8 or a 9 in order to be far enough away from the 4. So that's high. That's got to be 8 or 9. Actually, these 8s and 9s see each other, so I can't have any more 8s and 9s in this row. This has to be low because it can't be a 5 because there's a 5 right there. So that's low. That's 1, 2, 3, or... Whoops. That's 1, 2, 3, or 4. Actually, not 4 because there's a 4 in the box. This... Actually, yeah, this is high, this is low, because these can't be 5s, because there's a 5 there. So that is a 6 or a 7, because there's an 8 and a 9 in the box. Oh, this can't be a 3, because there's a 3 right here, obviously. So that's a 1 or a 2. For the same reason, this has to be 1 or a 2. Ah, here we go. So, these 1s and 2s, there's either a 1 here and a 2 there, or there's a 2 there and a 1 there. Either way... This can't be a 1 or a 2. This has got to be the 3. So that helps. Actually, for the same reason, this has to be a 6. In this row, the 1 and the 2 are already used. So that's got to be the 6, and that's a 3, and we can color that high. Actually, that's going to force a 7 into there. And that's going to be a 6, because it's the only unused number in this box. The 1 and the 2 belong down there. So there's no 6s here, and therefore there can be no 3s. So this is exactly 2 and 4 this way around. Okay, we're now really getting somewhere. This was a slow start. Oh, that's a 5. There's only one place for a 5 in the row, and it's there. This is going to be 1, 3, 7, and 9. We can probably make some eliminations. Yeah, this 1 knocks 1 out of here. Oh, actually, this 3 means there's no 3 there, but this 3 means there's no 3 there. So that's a 3, and it's low. Oh, this 9 knocks a 9 out of there, so that's a 7, and it's high. So there's no 7s in either of those. So they're 1 and a 9 somehow. I'm not going to color them, but I could have. And this is what's left in the row. That's 5 and 7. Again, I don't know exactly how that is. I could color them like this, but I don't feel like it. Okay, what else can we do here? This has to be, oh, so this has to be a 5 or high, right? If this is a 1, this could be a 5, and then we go to a 9 there. That's totally fine. Or it's just a regular high number. So in fact, this, well, it can't be an 8, but it must be a 5, 6, 7, or 9. What else can we do here? I suppose, oh, well, this has to be high, because it connects to a low number, and it can't be 5. So that is a 7, 8, or 9, because it's not a 6. This, well, this could be a 5, in fact. That could be a 5, 6, 7, 8, or 9. Not an 8. But. So that's a 7, 8, or 9. Huh. Well. Yeah, let me see here. I'll tell you what. If this is low, it must be 3. Because it sees a 1 and a 2 and a 4. Is that interesting at all? let me just look around the grid. I can take a 3 out of here. I can take a 6 out of here. Oh, I can take 3 and 6 out of here. I can take 3 and 6 out of here because they see this 3. And if there's no 3, there can be no 6. Is there anything else I'm missing? No? Is it okay for this to be a 3? Because if it's not a 3, and it's not a 1 or a 2 or a 4, then it must be 5, or it's a high number. If this is a 3... Yeah, I see no issues with that. Okay. I hope there's not something obvious staring me in the face, but there may be. Maybe I gotta think about this path here. Yeah. I don't know where this path goes, whether it's here or here. But wherever it goes, it must be low. It can't be a high, because that's too close to this high. And it can't be a 5, because there's a 5 in the column. So, whichever of these paths is taken, that must be a low number. But that does not imply that whichever of these paths are taken must be a high number. It could be a 5. Or could it? No, I don't believe it can. Yeah, because I'm thinking, oh, what if... Because I could go like 159 or 159. This is so cool. So, okay, I want you to think about this. Suppose I take this path here without loss of generality. So I probably go high, low, like this. Unless there is a 159 or a 951 trick. Could there be a 951? No, because there's a 5 in this column. So this is not a 5, this is low. But maybe it could be a low, and it's 159 like this. That's also not possible, because there's a 9 in this column already. So I can't go 9 to 5 to 1, and I can't go 1 to 5 to 9. So I must be low to high to... I suppose this could be a 5, though. But this is definitely a low, and this is definitely a high, if the path does travel that way. Oh, no, yeah, this can't now be a 5. Because a 5, the only high that a 5 connects to is a 9. So actually this is also a low. Which would make this either 5 or high, wouldn't it? Yeah. But this is definitely low. That's if the bottom path is used. But if the top path is used instead, it's the exact same thing. Because this 5 sees this square just like it saw that one, and the 9 sees these squares just like it saw these two. So it's the exact same logic, but flipped. So whichever of these paths are used, I don't actually know, but I don't care. What I know is that whichever of these two is used is low, whichever of these two is used is high, and then this one is low. So I can color it orange. And it is a... Oh, it must be a 4. Because it's not a 1 or a 2 or a 3. That is a 4. Interesting. How is that... Oh, I see how that's going to work. Yeah. In fact, I can almost get this entire box now. So, a 4... So now this has to be high. And a high can't connect to a high. So that's not high. It must be middle. It must be 5. So it must be 159 this way. So that's a 2. This 1 is going to see these 1s. And actually, this can't be a 2 anymore, because then the 2 has nothing to connect to. This is a 3 and a 6 for sure, which leaves a 2 and a 7 in the column. Okay. This takes a 2 out of that. So I suppose that can't be 1. Not that that does a whole lot. I suppose this also can't be 4. Which means that can't be 8. What else can we say? Well, yeah, what does this 4 connect to? Either here or here, it must connect to an 8. That's the only other thing far enough apart from 4. Because 4 only connects to 8 and 9, and there's a 9 in the box. So there has to be an 8 here or here. Actually, there can't be an 8 here, because it sees this 8. Yeah, if the rat were to travel this way, what can I put in here? It has to be far enough apart from 4, but it can't be an 8 or a 9, because it sees both of them. The 8 in the row and the 9 in the box. So in fact, I cannot travel this way. I must travel this way. So I have a high number and then a low number. Okay. Interesting. So what is this? That's where the 8 is then. This is either a 1, 2, or 3. In fact, either a 1 or a 3, because it sees this 2. This, I guess it can't... Oh! This can't be a 9 or an 8, because it sees them both in the box. So that's a 7. And that means this is a 2, and that's a 7. Because this 7 sees that square in the box. Which leaves what in this box? 1, 3, and 6? Oh, well, there's only now one place for the 6 in the box, because this 6 knocks out these. So there's the 6. And this is the other one of 1 or 3, whichever is unused. And I can resolve that immediately, because this 3 sees that square, so it must be a 1, that's a 3. Okay, good. Now, this can still be basically anything. Not quite sure how to proceed. That was a lot of... Oh, well, this 8 sees that, so that's not 8. This could still... Oh, well, that's not a 1. It's either a 3, 6... Oh, this 6 sees that. So that the only candidate left here that works on a black dot is a 2. So therefore, that must be a 4. And actually, that means we can't travel along this path, can we? Because a 2 and a 4 are too close. They're not 4 apart. Okay. I have to think that the rat is going to travel this way around, because this is just too direct, right? I guess something I can say, I can't use this path here, because what would be on the other side of this 4? Only an 8 or a 9, but there's already an 8 and a 9 up here in the column. Whoops. So that path can't be used. But I could use this one, for instance, if the cupcake has an 8 or a 9 on it. Right? In fact, I'm going to go ahead and color these so it's easier to see that. Well... Yeah, oh no, I'm just staring this right in the face. This 1 sees that square, so that's a 2 and that's a 1. And now this can't be the 5, it must be a high number. So we can take that out of there, and that, well, okay, this high number cannot be an 8. It's gotta be, what, 6, 7, or 9, doesn't it? Yeah, that's gotta be 6, 7, or 9. Now, I don't believe it's possible to use this path. Because what is this? It can't be a low, because that connects to a 4, and that's too close. It can't be a high, because that connects to either a 6, 7, or a 9, and that's too close. Even the 2 furthest apart high numbers are 6 and a 9, and those are 3 apart, which is not far enough. And it also can't be a 5, because a 5 connects to a 4, and that's too close. So this couldn't be anything if it was used on the path. So it cannot be used on the path. I must go this way. And whatever happens up here, I must also go this way. This can't be used because that's a dead end. Okay. Ah, so this is interesting. I cannot use this 2. I can't go in and out of the 2 like this, from here to the cupcake. Because what would this square be? It has to be far enough away from the 2, but the only numbers that are far enough away from the 2 are 6, 7, 8, and 9, and all 4 of those are already used in the column. So I cannot use this path. That makes a dead end here, which I can eliminate. That doesn't mean that I go this way around, because I could just go straight there, but I definitely don't go up and down from the 2. In fact, I may as well go ahead and mark these. The only two things left in the column are 1 and 5, and then the only two things left in this column are 8 and 9. Okay. Is there anything else we can do with that? So if this path is used, it must be 8, 1, 5, 9, or the reverse, because I can't connect a 5 to an 8. That's somewhat interesting. Well, let's see. What is that? It could be a 5, because it could connect to a 9, but it's definitely not high. It's either 5 or it's low. Oh, actually, it sees 1, 2, and 3. So the only low number it could be is a 4. So it's either a 4 or it's a 5. But there's no way this could be a 6, because that's too close to both of them. In fact, a 7 is also too close to both of them. This must be 9. And that sees this square, so that's an 8 and that's a 9. Actually, this 8, yeah, this sees an 8 and a 2, so it's neither of them. And that has to be a 2 or an 8. This can't be a 1, or that would be a 2. This can't be a 4, or that would be a 2 and an 8, and it can be neither. Again, that doesn't get us really anywhere, but maybe what are some other, like, almost finished units? Oh, this 4 sees that 4 because it's in the same box. How did I not notice that? You guys probably saw that already, but yeah, we can take, yeah, that's got to be 5. And a 5, oh, a 5 only connects to a 1 or a 9. So, can I use this path? I can't, because what would go in this square? Only a 1 or a 9, but it sees both in the box. So this is unused. I must go around this way. And let me just read this again. I cannot visit any cell more than once or cross itself. So there's no way of using any of this path because I would have to use all of it and that would form a loop. So I can take that out. Okay, what is this? Well, it's either a 1 or a 9, and it sees this 1, so it must be a 9. What is this? It must be a low number, and or it has to be a 5 or a low number, and it sees 2 and 4, so it must be 1, 3, or 5. That's all we can do for now, though. What's the rest of this box? 3, 6, and 7? This sees a 3 and a 6, so that is a 7. This is a 3 and a 6. Oh, and this sees this 3, so that's the 6. And that is the 3. This 3 also sees this 3 and knocks it out of there. These two are 2 and 9, aren't they? And this sees that 2. I think the coloring has served its purpose. I'm going to remove all of the color. I don't really think it's needed anymore. Okay, yeah, it's just kind of cluttering things. So, these are 2 and 9, and yes, we said that this 2 sees that square, so that's the 9, that's the 2. That can't be a 2, so it must be an 8. That now must be a 4. This 8 sees these 8s, so we can take 8 out of there. In fact, this is either a 1, 2 or a 2, 4, so it must contain a 2 for sure. That is interesting enough to mark, I think. The rest of this row is 1 and 7. This 7 sees that square, so that's a 1. That's a 7. Whoops. That's 7. That's a 1. This 1 sees that, so that's a 9. That's a 1. This 1 sees those, so that is exactly a 2 and a 4 in some order. What hasn't been used in this column? I've used a 1, 2 and a 4, a 3, 6, 7... Oh, I haven't used a 5 and an 8. Oh, and this 8 sees that, so that's the 5. Whoops. That is the 5, and that is the 8. What's left in this box? A 5 and a 6. That 5 sees that square, so that's a 5, that's a 6. What's left in this column? A 7 and a 9. I can't sort that out just yet. And then to finish the box, we need a 1, a 3, and a 6. Again, we can't quite sort that out. Yes, we can. A 3 cannot go in either of these two squares, can it? If that's a 3, what's that? A 1 is too close, a 6 is too close, and a 3 has already been used in the column and is too close. So that can't be a 3, and for the same reason that can't be a 3, so the 3 is there. So that's a 1 and a 6. In fact, we can't connect this 3 to whatever's in this square because it's too close. Or this square, right? Yeah, 1 and 6 are both too close, so we can't do that, and this would be a dead end, so we get rid of that. So we either go diagonally or we, like, zigzag. Okay. Oh, well, this 5 sees that square. That's got to be 1. And in this column, I need a 5 and an 8 to complete the column. Okay. Oh, that's a 6. It's the only thing left in the row. Oh, this 5 is going to see that 5 in this 7. So what's left in this column is a 2 and a 4. And I need a 3 and a 7 to finish the box. So how do I proceed from here? I still have yet to finish the bottom 2 rows. How am I going to do that? Oh, no, that doesn't quite work. This can't be a 5, can it? Because it's too close to this number. Whether that's a 2 or a 4, I don't care. That's too close to a 5, if that's a 5. So that's an 8, that's a 5. That's going to sort out the rest of the numbers, but I'm not going to put the last number in, because otherwise it's going to automatically, yeah, that's a 6, that's a 3, that's a 3, that's a 7, that's a 7, that's a 9, that's a 9, that's an 8. Oh, wait. Yeah, the 2s and the 4s I still haven't figured out. Okay. Let's go ahead and finish this path then. I obviously can't connect a 5 to a 6, and that makes this a dead end, so I have to go 1 to 6 there. What else? I can't connect a 7 to an 8, so I must go the long way around here. Whatever's in here, it can't connect to a 3, because it's too close. And they also can't connect to each other, because they're a 2 and a 4 in some order. So I must use this path, and since we know that the rat does not cross itself, I can't use this path, and that's a dead end, so I can't use this path, so I must do this. Now we finish the path. How are we going to sort out these 2s and 4s, though? Oh, well, if this is a 4, that's too close to that 7, so it must be a 2, and we finish this way. All right. 49 minutes, that's the fastest one so far, although, you know, I was taking a long time to explain how the puzzles and everything worked in the first couple videos. Anyway, experiment completed successfully, cells visited 39, black currants eaten 3. The transition to full-size maze appears to have had no negative effect on Finks's performance whatsoever. She showed high levels, oh, it's a she, alright. High levels of self-control, rejecting the black currants that would have been detrimental to her overall goal, whilst enjoying those, Marty is British, if you couldn't tell, whilst enjoying those that happen to lay on the correct path. I believe you mean lie on the correct path, but anyway. Alright, that was a pretty fun puzzle. So we've eaten, yes, 3 black currants, all of them being 4s and 8s. Alright, well, that's it for episode 3. I hope you guys enjoyed, and episode 4 will drop shortly. See ya.